Doing all that crap with no recording. Thanks a lot, Hank.
You're welcome.
Appreciate your help and all.
Don't act like we never heard of it yet.
Square root of 81. 9. Square root of x to the 4th. X squared. No. That'd be cube root of a to the 12th is a to the 4th. B to the 5th. Oh my goodness, Francis is like shooting things left and right. Oh. Cool. That's scary. X, the 4th root of x to the 12th. X to, it is not a meter. 4th root of y to the 16th. Y to the 4th. Is that my answer? No. He came from an even root and he's the odd power. Now if you look up this guy up here, why didn't I put it around him? Odd root, right? And we're okay coming out that way. Remember, that's why I have my little chant. Even root, odd power. It's like a little chant in my head every time I do it. Even root, odd power. Even root, odd power. That's working. What, Jimmy?
So, in example C,
Y to the 4th to protect himself without being. As he is all powerful. Yes, ma'am. Because see how it's a odd root, it's a cube root? And cube roots can come out negative, can't they? And that's why it's negative. So if the variable is negative, it'll come out negative. Does that make sense what I'm saying, Brett? Okay. Because I don't like green. Even though I'm wearing it. Okay. If I have 2 squared times 3 squared, that's what this is showing up here. That is the same thing as 6 squared. Notice, think about that really quick. That's 4 times 9, which is 36, and then that's same thing as 6 squared. If they have the same power, you can multiply their bases. Okay, that's a rule that some people don't really ever think about. So, why do we go with that? Well, if I have the square root of 3 times the square root of 5, what does that answer? It is, and because that's the same thing as 3 to the half, correct? Does that make sense to everyone? 5 to the half, and because they're the same power, I can multiply the bases. Does that make sense? So 3 times 5 is 15, underneath the square root, which is the 1/2. And just stretch it. Just stroke it off. Oh, I'm sorry, I apologize. So, can you simplify the product of this, which is the 4th root of 7 and the 5th root of 7? Not right now in its form. I would have to get a common root before I do that, right? We'll do those a little bit later. So this one's a no. How about the 5th root of -5 and the 5th root of -2? That would be the 5th root of 10. Once again, like I said, this is really piece of cake. That's why we're on page 4 of 50. And it goes up. Okay, once again, what's the cube root of 128? Anybody know? I don't know, so we're going to break it down. What's in 128? 8. That's good. Is that right? Yeah. I can do it now. So it's 8, 4 and 4. 2 and 4. Let's go to the 4, right? Group of 3, because remember, 1 gets sharp. Or in this case, 2 gets sharp. I don't know. takes a lot of people. This is like a federal prison. It takes more people to get out of. It's not like no podunk little state prison, you know. This is federal. It takes more people to get out. Exactly. Alcatraz, that's like a 10th room. Anyway, so 2 people get shot getting out of that sucker, right?
They have to sacrifice.
Exactly. They'll draw straws. He stays underneath because he didn't have buddies, right? Then we say to ourselves, self, how many times can 3 go into 7? 2 with 1 remainder, so I put x squared out here with 1 remainder on each side. Because instead of breaking it down like x, instead of doing groups of 3, where that's a group of 3 and that's a group of 3, you just divide it, saying how many times can 3 go into 7? Twice, right? With the 1 remainder. Hi, JC.
Is that a 3?
That is a cube root.
Okay.
I knew exactly where you're looking at, JC.
Okay.
I ain't worried about, well, yeah. 4th root of 64 was an x cubed, y to the 6th. Sure, we'll do that one anyway. Okay, what's in 64? There's my group of 4. This guy didn't have, well, he had 1 buddy, but he doesn't have 4, right? He doesn't even get out of his jail cell. He stays in yonder, or excuse me, 4 does. There's 2 times 4 is 4. You could make a lot of numbers out of this 2. Give me a number. Oh, that's a 6. A 6? Oh, come on now. 4. Now it ain't gonna work.
Draw the line on the bottom all the way across. Go the other way. No, on the 2.
Fun times, people. Fun times.
Oh, they're learning how to
You see what he did?
So, now we got, how many times can 4 go into x cubed? Yeah, so we stayed in it. You gotta have fun in math, and there's no point in being here. Okay? Enjoy what you're doing. 4 can go into 6 how many times? Once. With twice remainder. There's our answer. No! Yes, so bad.
Oh, wow. I totally missed that.
It's gonna be the biggest part you guys are gonna miss on the test, too. I'm waiting for you, Jim. What would you like to ask? Okay, brother, I'll come back to you when you're ready. Okay, because this is already simplified, well, not simplified because I can multiply these guys, but it asks you to simplify it later. Think about this. When I go 45 times 35, I'm going to get a number, but then I'm going to have to break them down anyway. Might as well just start right here and say, oh, 45 is 5 times 9, 5 times 7, 3, there's a group of 2, there's a group of 2, right? 3 times 5 is what? 15. Square root of 7, he has to stay in there. Everybody there with me? Now we got x to the 5th, and x, how many x's is that total? X to the 6th, the square root of x to the 6th is x to the 3rd. 2 can go to 6 3 times. Yes, you do. But might as well wait because maybe I have to do both times. Then I got y to the 3rd and y to the 4th. How many times can 2 go into y to the 7th? 3 times with 1 left over. So now, as Raven already ruined my thing, I have to put them around both, so I might as well wait and put them around both. Because once again, even root, odd powers. Okay? Sir, yes, sir. Okay? So the x cubed came because I have an x to the 5th here, and an x here. So that comes out to be a total of x to the 6th underneath the square root. Does that answer your question? Jimmy, James. I'm guessing you're going somewhere back with this, correct? So like why does this 4x cubed not matter? Why does the x cubed not matter basically? Is that what you, I don't know. Okay. Well, once again, it's the square root of x to the 5th, and so once again we're saying to ourselves we need pairs, right? Buddies. What is x to the 5th? X, 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 x. A lot of x. So therefore I'm grouping them. Right? So an x gets to come out, so does another x, so that's why it's x squared, with one guy still being in there. Or the way I do it quickly is I say to myself, what's the root? What's their overall power? And I say, how many times can 2 go into 5? Twice, with 1 left over. Because you had enough buddies, because that means there's 2 groups of 2 to get out, right? With the 1 left over. Does that answer your question? Jimmy. How many times can 2 go into 6? Onward. Page 6 now. Okay. This page basically talks about how like root 2 over root 3 is equivalent to root 2 divided by 3. Now why is this helpful? Well, if you can reduce these numbers, you should be able to divide them just to reduce. We can't. We're not done if that's the case. We're going to get to those pieces. But just understand, you can reduce. That's the only thing is they're making sure if you have it as one fraction, you can just do the radical over the top and the bottom. Or you can divide those numbers and see, like for example, on this guy right here, you can divide it. Square root of 50 over square root of 2. That's square root of 25, and that's a lot nicer, isn't it? You should always reduce before you rationalize. X to the 6 over x to the 4th. X squared. So now I'm just here, and that's pretty simple just to say it is 5x with absolute values. Last year I had a person I was wondering why you kept doing 1x1. They were like, I thought it was really funny. But I understood their problem. Okay, so now we're rationalizing, like this little buddy right here. Okay, so with that being said, can 7x and 5y squared reduce? They can. So I have the cube root of 7x over the cube root of 5y squared. Now, I don't know if you guys have ever done this when they're other than square roots. Have any of you guys rationalized other radicals before? Did you guys do that last year? I know in my class that was like going to be way too much for them, so I know I didn't do it, so I'm just kidding. Okay, so when we did a square root, we did the exact same thing because why? You needed groups of 2, didn't you? And so therefore, if you already had 1, you just did it again and it got exactly groups of 2. Does that make sense what I'm trying to go for there? Well, here we need groups of 3. So how many 5s do I have there? I have 1. So how many more 5s do I need? 2. Is that 10? Because that's 2 5s, or is that 25? Because it's 5 squared, so that's 25. Everybody understand what I mean by that? Yeah, thank you. 2 groups. And I have y squared. How many more y's do I need? I only need 1. Because if I already already got 2. Only need 1 more to get a group of 3. Make sense on that? So what I do to the bottom, you got to do to the top. Now, ladies and gentlemen, you only do this after you've simplified. Okay, only after you've simplified. So, what's 7 times 25? Quickly, right now. Oh my head. Count. Thank you, brother. You went quarter style. As soon as you put it on money, people are like, man, I gotta do. Some kids are like, I have no idea how to do multiplications. I'm like, you have 7 quarters. It's $1.75. It's the same thing. You just gotta put some numbers into money. I swear, people are like, I understand this. Oh, that's not horrible. Let's go back. So now, that has an X and a Y. Over. Now, we had 3 of these guys, so the 5 gets to come out. And that's Y cubed, so the Y gets to come out. If you've simplified at the beginning, you shouldn't have to do it in the end. That is the furthest I can go. L prepared. Time with Coop. We should just get used to it. Back recording. We are done with time with Coop. Okay, so we got the cube root of 12 over 10. What does that reduce down to? Cube root of 6 on top, right? Cube root of 5 downstairs, right? Is everybody with me? I have A and A cubed. So that means I'll have A squared down below. Just reducing right now. B squared on top, and then a C on top. So that's not too bad. That's actually the exact same thing we just did, to be honest, isn't it? So how many more? Because it's a cube root of 5A squared. How many more do I need? MP? Oops, that's a little harder than I thought it would have been. I'm really sorry. Apologize. Where did I lose you, MP? Where's the tossing? Because I got a good window here, huh? I worked hard for this one, babe. His body. You need money?
Yeah. No.
Yeah.
Look at this. I'll start you out on your fun.
Go get some stimulants.
A already comes in. B squared C over 5A. That is a 150 because remember we had 6 quarters. Hannah Honey. You're not Hannah Honey. There was a Hannah Honey, wasn't there?
Hannah Honey's right here.
I guess that's a great no. No, sir. No, sir. What's in 150? That's awesome, but there's no groups of 3. I'm going to tell you right now, if you reduce before you even rationalize the bottom, you're never going to have to rationalize the top. 5A.
That looks like a 9. 5.
There we go.
Okay, what's root 2 plus 3 root 2? 4 root 2. Awesome, okay. What's 1 root 5xy plus 8 root? Basically, we're combining like terms. Don't care about that. Onward. See, like this one. Can I say 7 cube root of 5 minus 4 square root of 5? Can I combine them? That's simplified. Okay? That's a simplified. Okay, what's 3x square root of xy plus 4x square root of xy? We better start you with pennies.
Oh my god.
Sorry if that was rude, but it just came right out. J.C. Penney. And I didn't even think of that. That's funny. Hey, I actually shop at, they have a big and tall store. What if it was this way? Can I combine those? 3x square root of xy plus 4 square root of xy. You could do this. Factor that out. I'm just talking in general. Depends. Not like the underwear.
I'm surprised that you know that.
My grandmother. I don't. Hopefully, I don't have to take care of my parents for this.
What's funny is when the girls were bald and like bald, how many people wear diapers, and then when you're the guy, you're bald, and how many people wear diapers.
You thought a lot about that, didn't you?
No, not really.
Cube root of 150. I'm just going to tell you it's 5 cube root of whatever. It's 5 cube root of 2. Cube root of 54 is 3 cube root of 2. Cube root of negative 6 versus negative cube root of 16 is minus 2 cube root of 2. So first off, yes sir, those are cube roots. I know it's not, it's why there's a 2 still underneath there. Would you like me to show you? I can do it, because I'm a nice guy. 250. 5 quarters.
Oh, it is.
Oh. So hence I got a group of 3, right? Whenever I see things, yeah, I get the money. Because our mind likes money, huh? Yeah. Money, money, money. 8 minus 2 is 6. Cube root of 2 is...
Yes.
Yay! Foil! I love me some foiling. Why? Well, then don't do foil. Do the area model.
No, I hate those things.
Yeah, I'm talking about actual foil.
No. You just made me do this area model shit.
I do that every way foil, but I'm talking about
6. 12 root 5. 4 root 5. 40. How do we get 40 though? Most people have a hard time seeing the 40. James. Dave. Because it's 4 times the 2, and then what's root 5 times root 5? 5, so that's where the 40 came from. So notice I get 46 plus 16 root 5. What do we know about conjugates, ladies and gentlemen? No problem. I apologize for my wrongdoing to you and your family. This is yours.
I don't want it.
Well, there's nice littles.
Oh my god.
Robert, just keep trying to be off topic. Hey, once again, these guys are called conjugates. We've talked about conjugates in the past, right? A difference of squares goes into conjugate pairs, don't they? Okay? So with that being said, when we multiply conjugates, what's the nice thing about conjugates? What do? The middle terms, I'll just show you really quick. And then that's root 12, that's minus 12. So the middle terms always reduce out, right? That's the nice thing about conjugates, correct? So that just becomes 24, hot dog. All right, I'm not going to do the second part of that. But when we have, what? It is, that's why I'm rewriting it.
Oh, I see what you mean.
Okay, so, awesome. Okay, with that being said, what don't we like down here? We don't like square roots in our denominator, do we? So what do I have to do? times them by what? Its conjugate. I times by its conjugate, because it will get rid of the middle terms that we'll have, because when I go root 3 times root 3, that gives me just 3, right? You get what I'm saying by that?
Yes, sir.
So, think about that, and then when we multiply this, we get 2 root 7 times root 3, which is 2 root 21. 2 root 7 times root 5 is plus 2 root 35. I'm so sore today. That was the back. Wasn't
Oh,
the
okay.
desk. I don't like my back. No. Ugh, I'm sore. I don't know why. Storms are coming. Root 3 times. I can feel them. You can. Pressure. Pressure up. Like I get stiff. Oh, it's metal from right there to there. A hip replacement? Oh, I forgot about that. But yeah. So like, every time I go to the freaking airport, it takes me a half hour. The scanner, it depends. I don't know. Well, I went through the last times root 3 is 3. Root 3 times root 5 is root 15, but that's going to be minus root 15. That's the whole reason why we did conjugates, right? So that the inner and outer pair of FOIL will reduce out. Does that make sense why we do conjugate pairs there? Okay, and then notice what negative root 5 times a root 5 minus 5. So then I'm at 2 root 21 plus 2 root 35 over negative 2. Is that my answer? No. These guys, this, and this all have what in common? 2. So that becomes negative root 21 minus root 35. Because I divided 2 by negative 2. You good? I think we're almost there. Okay. What happens, ladies and gentlemen? We just went over that. Let's skip that. Skip that. Okay. So, really quick here. Oh. Okay, cool. If I have the cube root of 3 times the fourth root of 3, I mean the square root of 3 and the fourth root of 3. Is there anything I can do to simplify this? Yes, they are, because they are like bases. Because they are like bases, what can I do to the exponent? Give me a hint. Oh, you add the exponent, right? X squared times x is x cubed, correct? So this is 3 to the half times 3 to the fourth. It will be 3/4, but how did you do that officially? 2/4, right? In a common denominator. And then we add, so that's 3 to the 3/4, which is the fourth root of 3 cubed, or the fourth root of 27. Everybody there with me? Like basis, when I said x, like what you just said, Hannah, to see if to answer your question. If I said x squared times x, I didn't say x squared cubed, did I? That makes sense why I didn't do that. What happens when I have division? If I had x to the 3 halves, that's what this is because it's the square root of x cubed, over x to the 2/3. So on multiplication, I add. On division, if they're like bases, what do? Subtract. Do you guys remember these rules? I just taught them to my secondary 2 kids, so hopefully you guys did. So that's x to the 9/6 over x to the 4/6, which comes out to be x to the 5/5 6. Who just said 5/6? So, okay. Some things I want you to be able to do in your head. Like this one. You shouldn't even have to use a machine on this one. Anybody tell me what this answer is right now? I heard a lot of answers that were none of them were right. Still not getting there.
Solving. Stand by.
By the way, it's called simplifying.
8.
It is 8. Okay, why? What does that 4 on the bottom mean? The fourth root, right? So it's the fourth root of 16 cubed, or the fourth root of 16 cubed. I would prefer to do this one first, correct? Because what is the fourth root of 16? 2 and 2 cubed is 8. Make sense? Okay. Next one. That's it. We're done.